Okay, one more of these problems that involve work. Martin can paint a fence in 40 minutes. Matt can paint the same fence in 50 minutes, just like the last couple three. How long will it take them to paint the fence working together? So I'm going to let T be the time working together. Okay, now Martin can paint the fence in 40 minutes. So if he works for T minutes, he's going to get T 40ths of the job done. Remember, it's the time working together over the individual time. And that's the fraction of the job that Martin gets done. Matt can paint the same fence in 50 minutes. So if he works for T minutes, he gets T 50ths of the job done. That's the fraction of the job that Matt does. And if they work together, the fraction of the job better be 1 if the job is to be done. 1 completed job. How long will it take them to paint the fence working together? My least common denominator this time is 200. 4 and 5 is 20, and then you add a 0. So 200 times T over 40 plus 200 times T over 50 equals 200 times 1. Don't forget to multiply both sides by the LCD. That's a 5, so I have 5T plus 50 goes in. 4 times 4T is equal to 200 times 1 is 200. 9T is equal to 200. Divide by 9. T is equal to 22 and 2/9 if I'm not mistaken. So I just divided 9 into there. I'm not going to write it out as a decimal. I'm going to write it out as a mixed number with a fraction. So together, they can paint the fence in 22 and 2/9 minutes. And that's my answer. Alright, now the next 5 problems are all somewhat similar problems. I mean, all you have to do is look at the wording and you can see they're similar. So I'm going to spend a little bit more time with the first one, and then I'm going to show you that by the time we get to 19 and the time we get to 21, they add a little twist to each problem. 17 and 18 are very, very similar problems. So I'm going to show you how to work with 17. Now, before I do, I'm going to erase some of this. So, of course, you can always rewind your video and such, but make sure you've tried this one. This is not going to give you an equation that's that has rational expressions in it. It's going to be a pretty straightforward problem. But I kind of wanted to make sure you understand what I'm talking about here. So I'm going to erase this part, kind of draw a picture of what's going on just about every one of these problems. You've got 2 cities. You've got city A here, and you've got city B here. You've got 2 vehicles that are leaving the 2 cities traveling towards one another. So you got one guy going this way, you got one guy going this way. In the first 2 problems, they leave the cities at the same time. They go at different rates. The distance between the cities is some amount, like in problem 17, it's 490 miles apart. So it'd be 490 miles apart. Okay? So what we're going to do here is we're going to figure out how long will it take before the cars pass each other or practically just meet one another. Because remember, one of the cars is going this way, one of the cars is going this way. Eventually, they're going to pass one another, hopefully on different sides of the street. Alright, now in this case, you've got the truck leaves city A and heads for city B, traveling at 60 miles an hour. I hope that you will remember that distance is equal to rate times time. You're going to need to remember this. Distance equals rate times time. At the same time, a car leaves city B, heads for city A, traveling at 80 miles an hour. So this car is going a little faster. He's going at 80. The distance between the cities A and city B is 490 miles. So that's what I indicated there. After how much time will the 2 cars pass each other? What I'm going to do here is I'm going to figure out how far did car A travel, and then I'm going to figure out also how far car B traveled, and I'm going to add those 2 distances, the pink and the blue here, and I'm going to set it equal to 490 miles. Because the distance the one travels plus the distance the other travels, if they meet or pass one another, that's a total distance of 490 miles. Now, sometimes it helps if you draw the picture out for a problem like this, and I would suggest that you do that. They're all very similar, and they're all, going towards one another, so it's going to be kind of the same diagram each time with different distances here. Now remember, distance equals rate times time. We don't know how much time, we don't know how many hours, if it's 1 hour or 2 hours or 3 hours. So my unknown here is t, is the time traveled. Okay? Because they left at the same time and they passed one another at the same time, whatever the time is for the truck, it's the same as the car. Because they're leaving at the same time and they're arriving at the same time. If one of them gets a head start, then they've traveled for more time and the other vehicles traveled for less time. But in this case, it's the same amount of time. Now remember, I just said distance equals rate times time. The truck, this is the truck going this way here, because it left city A, is going at 60 miles an hour. For t hours, 60 times t, he goes 60t a distance. This is the rate times the time. We just don't know the time yet. Okay, the other guy, he's going, the car is going this way from city B, and he's going 80 miles an hour. So in t hours, that's 80t. And as I mentioned before, if I add these two distances together, it should equal how far apart the cities are, 490. So look how simple the equation is. 60t plus 80t is equal to the distance between the cities, 490. This isn't so bad. You've got like terms, you have no fraction, so you don't have to worry about multiplying through. Combine like terms, you get 140t is equal to 490. Divide both sides by 140. And if I'm not mistaken, it goes in 3.5 times. Now you can double check my arithmetic, 3.5 on your calculator, and you can use a decimal here because it's a little more convenient. So it says after how much time will the two vehicles pass each other? It's going to take 3.5 hours. The two vehicles will pass each other, in 3.5 hours. Don't forget your hours. Don't forget your units. Write out your answer in a sentence. This next problem is almost identical. So again, if you haven't done problem number 18 after seeing problem 17 work, stop the video, try problem number 18, and then you can check your work and put the video back on and check it. Alright, so I'm going to go ahead and do it now. A bus leaves city A traveling for city B at 80 miles an hour. So it's kind of the same effect here. I'll go ahead and I'll put, here's A, here's B. One's going this way at 80 miles an hour. At the same time, a van leaves city B and heads for city A, so he's going this way at 70 miles an hour. The distance between the two cities, this distance here, is 1,200 miles. Okay? So we want to know how much time will it take the two automobiles to pass each other. Practically the same problem. A couple different numbers. So again, I'm going to let t be the time traveled. I don't have a lot of extra space here because I'm trying to squeeze 6 problems in. So remember, the rate times the time is the distance. Rate times time is distance. So my rate for the bus that's going this way is 80 miles an hour. I don't want to be on that bus. So for t hours, rate times time, that would be 80t. Okay, over here you got a van that's going 70 miles an hour towards city A, also traveling for t hours. He's going 70t. And if we combine those, it should end up being the distance between the cities before they pass one another. So 80t plus 70t is going to equal 1,200. That's 150t. I combine like terms. I divide by 150. The equations are pretty simple so far. T is equal to, let's see, 8, if I'm not mistaken. 1,200 divided by 150 is 8. So it says how much time will the two vehicles pass each other? The two vehicles or automobiles will pass each other in 8 hours. Or 8 hours after they start. Okay? It doesn't say when they started. Like if they said they started at noon, then they would pass each other 8 hours later, that'd be 8 p.m. Alright. Now problem 19 and 20 have the same kind of a little twist to it. So does 21, but 21 kind of states the question differently. It says, at 2 p.m. a bus leaves City A headed for City B traveling at 60 miles an hour. At 3 p.m. an hour later, a truck leaves City B and heads for City A traveling at 70 miles an hour. The distance between City A and City B is 580 miles. At what time will the two automobiles pass each other? It's almost the same problem, except they don't travel for the same time. This guy starts an hour later. He doesn't travel as long. So if I let T be the time the bus travels, the first vehicle, remember I left it 2, then T minus 1 would be the time the, what was it, the truck travels. Oh, I forgot to write travels. Okay? Now you say, well, what if I made this one T? Then this is an hour more because you got an hour head start, so this would be T plus 1. But we're going to just leave it as is. Now remember, you got the two vehicles here. Here's City A. Here's City B. They are 580 miles apart. So this one gets a head start. He starts driving. Then after an hour, this guy, the truck, starts driving. So this guy's still going as this guy goes. This guy's still going as this guy goes. But eventually they pass one another because they're headed towards one another. And we just have to figure out at what time they're going to pass one another. So I'm going to have to figure out what T is. Now remember, rate times time is distance. So for the first vehicle, it traveled for T hours at 60 miles an hour. This would be 60 T. The second vehicle travels for T minus 1, an hour later. T minus 1 hours at 70 miles an hour. So this would be 70 times T minus 1. Rate times time, rate times time. And if I add those together, I get the distance apart, which is 580 miles apart. So 60T, that's the bus, plus 70 times T minus 1, that's the truck, is going to give me a grand total of 580 miles. So I have an extra step, or 2. I have to distribute. I get 60T plus 70T minus 70 is equal to 580. Combine like terms. 130T minus 70 is equal to 580. Add 70 to both sides because you're solving for T. No quadratics here. 130T is equal to 650. Divide both sides by 130 and T is 5. Now what does that mean? That means T, which was the bus, takes 5 hours. The truck only travels for 5 minus 1 hours, 4 hours. If the bus leaves at 2 and it takes 5 hours, it's 7 o'clock in the afternoon, in the evening. At what time will the two autos pass each other? The two automobiles will pass each other. Remember, 5 hours after the bus left, so 5 hours after 2 p.m. is 7 p.m., will pass each other at 7 p.m. If you plug the 5 in here, 5 minus 1 is 4, so that would be 4 hours for the truck. Remember, he left at 3, so 4 hours later would be still 7 p.m. That's when they'll pass one another. There's that little twist there because they had different starting times. The same thing for problem 20. So if this makes sense to you, before you watch me work this one out, you try this one and see how you do. See if you get an answer that matches up, because I'm going to work it out now. Alright, so at 10 a.m. a truck leaves City A headed for City B traveling at 60 miles an hour. At noon a car leaves City B and headed for City A traveling at 80 miles an hour. It's that same idea. Here's A, here's B, and they're traveling towards one another. It's just that this guy starts at 10, this guy starts at noon. That's 2 hours later. 2 hours later instead of 1. Alright, so it says here the distance between the cities is 400 miles, so that's this distance here. 400 miles, right? At what time will the two automobiles pass each other? Well, again, the first guy gets the head start. He leaves at 10. He travels for 2 hours before this guy even leaves. Then when this guy leaves, remember, he's still going forward. This guy starts. This guy's going forward. This guy starts. Eventually, they pass each other. But how far did each one travel before they passed each other? Well, if we let T be the time the truck traveled, That means since the the car started 2 hours later at noon, it would be 2 hours less than the truck would be the time the what did I just say? The car traveled. So now what I'm going to do is I'm going to use rate times time is distance. So maybe a different color will make this easier to see since it's getting so messy. This guy goes at 60 miles an hour for t hours. This is 60t. This guy here goes at 80 miles an hour for t minus 2 hours. This would be 80 times the quantity t minus 2. And if we add those together, we better get the distance apart, which is 400 miles. So 60t plus 80 times t minus 2 is equal to 400 miles. Just like the last problem, I have to distribute 60t plus 80t minus 160, 8 times 2, 160, equals 400. Combine like terms, 140t minus 160 is 400. Add 160, if I can squeeze all this in, I get 140t is equal to 560. Divide both sides by 140. T is 560 divided by 140 is 4. Now check it with your calculator. So that means that at 10 a.m. the truck leaves and travels for 4 hours. Right? 4 hours is T. At what time do they pass? 4 hours after the truck leaves, 4 hours after 10 a.m. That'd be 2 in the afternoon. So the two automobiles will pass each other at 2 p.m. Put the time down. Don't just write down 4 hours or something like that, because then technically you haven't really answered the question. All right, now 21, when I read this problem the first time, I thought it was the same thing as 19 and 20, and mostly it is. They just put a little twist to the way they ask the question. They're not asking how much time, they're asking how much distance. So we're going to have to make a substitution. But we do everything else the same. In fact, to allow myself enough space here, I'm just going to go ahead and kind of erase a little bit right here. And it says here, you've got city A, you've got city B, you've got a van leaves city A for city B traveling at 80 miles an hour at noon, at 12 p.m. Okay? He's going this way. Now, at 1 p.m., an hour later, a car leaves city B traveling for city A. So this one starts going, and this guy's already going, and this guy is going, and this guy is going, and eventually they meet and pass one another. All right, so distance equals rate times time. Rate times time is distance. Speaking of distance, the distance between the cities is 545 miles. So if the distance that the vehicle, the van, and the distance that the car travel better add up to 540 when they pass one another, because that's when they've completed the distance between. So in this case, at 80 miles an hour, we're going to let t represent the time the van traveled. And we're going to let an hour later, so t minus 1, be the time the, car traveled. So my distance here at 80 miles an hour for t hours, this is 80t. My distance here at 75 miles an hour for t minus 1 hours is 75 times t minus 1. Rate times time. So if I add these together, I better get 545. So I'll put it down here. Maybe I can squeeze it in there, but I'll write this first one down. 80t plus 75 times t minus 1 is equal to a distance of 545 miles. I distribute 80t plus 75t minus 75 is equal to 545. Combine like terms, 155t minus 75 is equal to 545. If I add 75 to both sides, I'm running out of space here. I get, I'm coming over here, 155t equals, what would that be, 620. I divide both sides by 155, and t is equal to 4. So if the van left at noon and traveled for 4 hours, that means they finally meet and pass one another at 4 p.m. because they left at noon. But that's not what it's asking. It doesn't say what time, it says how far. Well, this is the key. Because not only does that tell me the time, I can use that and I can plug it into here and figure out how far from city A the van traveled. Because it says how far from city A. So I'm plugging it into here from city A. If they said how far from city B, I'd be plugging it into here. So I'm going to plug 4 right in there. I'd have 80 times 4, that's 320 miles. So how far from city A will the two pass each other? The two automobiles will pass each other. Will pass, whoops, let's see if I can write it. Will pass each other 320 miles from city A. And that answers that question. You can see how similar these last 5 problems are, but they did add little twist each time. Now, the last problem, problem 22, which I don't have written up here, is a peach. In this case, they are doing a word kind of a problem, but they're adding a bit of a twist to it. So I'm going to work it out, but I'm going to just save this one for its own video. So you make sure of these and then give problem 22 a try before you watch the next video.